Last time we just looked at parabolas and identified different attributes and characteristics of the quadratic, but today we're going to be graphing those quadratics together. We'll do a couple examples, really just plotting coordinate points, drawing our parabolas, and then labeling all of that same vocabulary from last time. Now what's going to be helpful is to actually have a Desmos open so that you can use Desmos to graph. So this little video right here is going to graph the equation that is given to you on the front page of your notes. Now what's cool about Desmos is that when you graph it, you can highlight the line or the curve and select the different important attributes or points from the line itself. So I am able to quickly see that this graph is going to have some very important attributes. We see that it has a vertex at -2, -9. So I'm going to go ahead and plot that coordinate point and talk about my vertex. Now, we also know that in that vertex is also my axis of symmetry, x equal -2, which means I should make a very symmetrical parabola pretty much centered on or being able to be folded on this invisible vertical line. I also know that it has the roots, zeros, x-intercepts, and solutions of -5 and 1. So I can fill that in both on the graph and here in the table. Sorry, that's not a table, it's just a list of attributes. One thing I want you to know is that when I ask you about x-intercepts, there will be times that the answers are just looking for you to give it to me as a coordinate point or 2 coordinate points for the x-intercepts. But really, if you just said -5 and 1 for any of the 4 rocks words, that would be fine. Now, last thing that the Desmos will give you is the y-intercept, 0, -5. It is also my c value. So in standard form, it's going to be that last number, -5. My y-intercept is 0, -5. Now, we can go ahead and graph our parabola here. So I'm going to grab a different color. I'm going to kind of try to do my best to make this as U-shaped as possible. You're definitely allowed to laugh at my wobbly lines, but there you go. There's my good sketch and my graph of the parabola. Now that I see it on my paper, I can tell that this does not have a maximum, it has a minimum value. And that minimum, the lowest it goes, is -9. And the domain, since it never stops on the left or the right, is all real numbers. And the range, since it has a minimum value, all of the y values are going to be above, because -9 is the smallest, so it all should be above -9. And that's what we're going to be practicing today, folks. We're going to be graphing these parabolas and then just talking about the different parts of the quadratic function again. So let's pop on over to the inside and let's get the second one going. Please try to do better at graphing than I did. You guys kind of know I'm quite terrible at graphing, but here we go. So again, I would open up Desmos for number 1, f of x equal to x squared minus 2x minus 3. And I'm going to use a Desmos graph to graph it for me. I just go ahead and type it in and then select the line. And again, all of the important attributes are able to be clicked. So I will know the different attributes for this parabola. I can just go ahead and graph them. Okay, this says that we would have a vertex at 1, -4. So 1, -4, that's the lowest point there, 1, -4. And we know that the axis of symmetry goes right through that vertex. That invisible vertical line that cuts the parabola into half is the equation x equal 1 because it's a Vux line. I can also tell that this parabola has the roots, zeros, x-intercepts, and solutions of -1 and 3. So I can graph that and then include it on my list of things, -1 and 3. -1 and 3. Again, x-intercepts are coordinate points, so technically I should answer this as -1, 0 and 3, 0, but -1 and 3 communicates the point well to me anyways. We also have a y-intercept of -3, so 0, -3. Again, my c value is there. Now I can graph my curve. Do my best here. Hey, that side's not too bad. Let's see if I can do it on this side. Not too shabby. There's a good parabola for you. This parabola also doesn't have a maximum and only has a minimum value, and that minimum value, the lowest that it goes, is -4. Because that's the lowest point, the point of my vertex. That's how high or low my vertex is. Again, the domain of any non-bounded quadratic function is all real numbers because it's going to continue extending left and right till forever. But its range, since it has a minimum, is going to be above that minimum value of -4. So greater than or equal to is the above symbol. Now I'm going to give you a visual of the next parabola with the video of it, but I want you to pause the video and try to see if you can fill out the different attributes for this particular parabola. So here it comes. So there are all of the attributes that I'm giving you. See if you can figure out the rest of this parabola's information for this particular question. So I'll scoot it over. Go ahead and pause the video. Hopefully you noticed a couple things. One thing I would hope you notice is that this is a really wide parabola. Cool. It's a wide parabola. That works. It has a vertex at 0,4, which means that its axis of symmetry is the equation x equals 0. That's the vertical line that cuts this parabola into two symmetrical pieces. Its rocks, its root zeros, x-intercepts, and solutions are at -6 and 6. And its y-intercept is also its vertex, which is totally fine for it to play double duty. It can both be the y-intercept and the vertex. Remember that y-intercept, you can also check and make sure that it's the same as the c value from your equation, the straight up number. Now I didn't answer the domain and range here. I'll answer it with you now. The domain, since it doesn't stop on the left or the right, is going to go from -infinity to +infinity, or all real numbers. Now the range is a little bit different than the two examples you'd seen so far. Since this one has a maximum value, then that maximum value is 4. We know nothing can be bigger than 4. So we're going to say that all of the y values are less than or equal to 4. So that symbol flips over because it is less than. It should look like your left hand. All right, I'm going to take some of the training rules off. On this third equation here, on the third parabola, I'm going to let you do all the work. So you open up a Desmos, you type in this equation to Desmos so you can see all of those attributes. And when you unpause the video, we'll have all the attributes on the screen. So go ahead and give it a shot. Graph the function and tell me its attributes. Yeah, so hopefully you noticed this one got a little bit out of hand. Two of the coordinate points we needed, the vertex and the y-intercept, were off the graph that I gave you, but you can always just estimate, okay? We're making good sketches here. So you could zoom out a little bit on Desmos and then identify all of the parts. We have a vertex at 3.5, 12.5, which means my axis of symmetry is the vertical line x equal 3.5, which means the vertical line cutting right through the middle of that vertex. The root zeros, x-intercepts, and solutions are at 1 and 6. The y-intercept is again off the grid at 0, -12. We know this because it's the c value. Now, since this one is a frowny parabola, it has a maximum value. That maximum height that it gets to is 12.5, which means that the domain is all real numbers, but the range is all of the y values less than or equal to, meaning below, 12.5, since that is my highest point. So it doesn't matter if it goes off the grid a little bit. You're still sketching me the parabola and finding me all of these attributes. Now this last one we're going to do together. This one has a really, really special function, okay? You can kind of tell based on how it's written, f of x equal x squared, that there's not a lot going on here. It's just an x squared. This is what I like to call, and that what is actually called, this is actually its name, I didn't just make this up. This is known as the parent function. So what I think about the parent function, I think about how it is the function that starts all the rest of them. It is the most #basic version. Yes, I just used a hashtag. It is the most #basic version of a quadratic. So here's a video that's going to show you this one being graphed. Okay, here it comes. So here's my parent function, and it only has one little attribute that shows up. I'm going to go ahead and make it dashed. This is how I like to show the parent function, because it is the most basic version of a quadratic that we have. Okay, let's go ahead and answer all these questions, and you'll kind of see why we call it the parent function. So the only coordinate point I have is this one, and then it is a positive parabola, which means it opens up. All right, let's do what we know. We have our vertex. It's the turning point of the graph, highest or lowest point. That's right there. That's 0, 0, which means the axis of symmetry cuts it right in half right here, or at x equals 0. Its root 0, x-intercept, and solution is also right there, which means it has a root of 0, a 0 of 0, an x-intercept of 0, 0, and a solution of 0. Guess what its y-intercept is? It's also right there, which means its y-intercept is 0, 0. It doesn't have a maximum, it does have a minimum, but guess what that minimum value is? 0. Its domain is all real numbers just like everybody else, but its range is everything bigger than, you guessed it, 0. Okay, you see how all of these numbers are 0? This is a really boring function. Okay, it is the most basic version. It is like the starting block version of all other parabolas, because it goes through the origin for all of its important attributes, and it's positive. So it's called the parent function. Now this parent function is going to be very important to know about when we get into our next couple lessons on what are called transformations of quadratics. Just so you know, it always starts here with this super boring parent function. So the goal of today was to be able to graph these functions as well as still go over those attributes of them that we learned about last class. Hopefully this vocabulary is starting to stick, and hopefully your parabolas look a little bit better than mine. I'm bad at drawing. Y'all have a good day. See you in class.